Hello and welcome to this presentation, Poka-yoke in Production Engineering with Teamcenter and Technomatics. My name is Gert Nonden and I work as a digital factory consultant at Cards PLM Solutions. In my daily life, I conduct a lot of simulations of production and logistics operations, including the production engineering and supply chain management topics that are involved. I have a special focus on the integration of these simulation tools with systems like Teamcenter, PLCs, and manufacturing execution systems. Over the years, I've worked in many industries, including automotive, truck, machinery, shipbuilding, aerospace, food and beverage, tire, and so on. In my title, I use the term Poka-yoke, so let me introduce this concept a bit further. Poka-yoke, or mistake-proofing, involves adding steps or manual or automated checking devices to eliminate inadvertent error. However, Poka-yoke is not limited to manufacturing operations. In fact, it can apply to all production and service processes, including production engineering. I will show you how this works by using a practical example. But first, some positioning. Our starting point is a product design. Nowadays, nearly all products are developed using CAD tools in 3D, including data management systems. This product design forms the starting point to think about production. First, however, we will build up the production system in a virtual environment. This way we can optimize the production without making big investments. Once we have optimized the production and made sure it will deliver the right amount at the right time, we can start up the real production to deliver the real product. It doesn't end there, because we also want to create feedback loops using IoT and big data. So we get a feedback loop to feedback information how the product performs in the marketplace, but we also want to create a continuous optimization loop between the real production using the virtual production model. So the product design forms the starting point for our production engineering. With the product information at hand, we will start adding additional information. This involves work instructions, quality documentation, but also automation-related information, ramp-up, and in the end also maintenance-related data. To make it more clear, I will show you a small example of a product. This is the NanoBox. It's an industrial PC designed for industrial environments. It's high performance and very robust, and it fits in a very small space. I will use this example to show how Poka-yoke can be used for production engineering. The first step is to take the product design and specify some basic information. We do this using a manufacturing process planning environment. This is based on a Teamcenter platform where we first take the product as it is designed and translate it into the product how it is to be made. To do this, we will create a bill of process, also known as routing, and this contains basic information like the tasks needed to make the product, the timings, also the material requirements, and where needed, instructions for workers or for machines, and also the resources that are needed. And actually, this is a very important step in the journey. On the screen here, you see a lot of colors, a lot of different colors. By using comparison algorithms, the user can check whether the manufacturing bill of material and the bill of processes is complete and up to date. This is a very simple but very important first check. So what do we have? On the left, the products, what we have to make. On the right, we have the processes, how we are going to make this product. But please also keep in mind that the data on the left remains connected to the data on the right. Using the same system, using the same data, we can add digital work instructions, building on the digital model that we have already gotten from the product development. The information can be made available in many different ways, but one thing is very important, because as you can see, the product design information is reused, and therefore, if there is a change for whatever reason, it is very easy to trace which work instructions are affected and have to be updated. The next step concerns the configuration on the shop floor. One of the tools that we can use is a virtual mannequin, a virtual person that has to do some manual task using tools. So here we check the feasibility of this operation for a human. Can the person reach the tools? Can it reach the product? Can it perform the task? And how well would it do so? How much time would be taken? And in addition, we can also check the ergonomic loads on this person. By visualizing ergonomic risks, we can do something about them. We need to check many things at the same time. Sometimes they are very detailed, like the previous demonstration, but they can also be of a more strategic importance. Once we have a rough idea of how many products we want to make, what the timings are, we can also build a dynamic virtual model of the complete production system. Here we use a tool called plant simulation. The tool simulates the flow of materials through a production plant. During this simulation, the objects in the model gather all kinds of information. For instance, how much work they have done, how much downtime they have had. And this is a real dynamic model. So if there is no material available in a workstation, the workstation will really not perform any work for that time period. By testing against different strategies, different policies, different capacities, we can optimize the production system. In the next step, we can work on line balancing. And line balancing, for one thing, involves making use of constraints between operations. Just like building a house, first you have to start with a foundation, then you can make the floor, then you can build up the walls. Once you have the walls in place, you can do many other things like plasterwork, windows, etc. These constraints can also be implemented in the same production planning environment. By using this information, it is quite easy to see where unbalances are. Like in the picture, we see a few tasks in a station that overload the operation. So we can and should definitely redistribute these tasks to other stations. So now we have taken the information that we were working on even further. We have the process structure, we know how to make the product, but now we have also linked this information to our production plant. We also define where it's made. We distributed the tasks over the workstations and the workers, and we can see where bottlenecks will appear. There are 4 pillars to this so-called Smart Innovation portfolio. First of all, we want to give the right information to the users at the right time. So a production engineer should and will use different tools than a product developer. Another important pillar is the use of intelligent models. Remember the humans that you saw? The humans know what movements they can make, and they work goal-oriented. This helps in speeding up the creation of these simulations. In addition, they also know when they are becoming overloaded and get into risky positions. Nevertheless, of course, we work on virtual products and virtual production first, but in the end, it all is about making real products and delivering them to real clients. And of course, these clients have feedback, and so we also want to be adaptive. And feedback, new information, new circumstances into our system and update our production accordingly. This is called the Smart Innovation Portfolio. So, what is Poka-yoke in production engineering? Well, it is to know that your design can be made, that your production plans are up to date and synchronized, that the production system is up to date, that it will work both at the strategic level, but also that critical details have been checked and tested. And we know by using smart simulation tools where we can improve and optimize the performance. And in the end, production is performed as we planned it. Thank you for your attention and enjoy the rest of your day.